Hey folks, you're listening to the Java Easily podcast, episode number 5. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Now, as always, just before we get started, you might be completely new to Java, be a complete beginner, and if you are, and you haven't yet grabbed our Java Beginners Starter Kit completely for free, then go over to our website at javaeasily.com and go grab it there. It's a super helpful guide designed for complete beginners, and it's going to get you up and running with Java in the shortest time possible. But anyway, on with the episode. Now, the first few podcasts that we did were pretty much geared towards intermediate developers. And what I mean by that are Java developers who they're already using Java in some capacity, whether it's professionally as a kind of a intermediate level Java developer, or otherwise they've been using it for some time now on a personal level, so privately at home for example, and they're familiar enough with the programming language, the platform, how Java works, how it all hangs together at a base foundational level to be able to want to know about those kind of more advanced concepts which we've been talking about. And we've got a lot more good stuff as well down the line, which we're going to talk about for the intermediate developers amongst you, so don't worry with this episode. Still going to get those kind of episodes out to you as well. But what we do want to do, for these next few episodes at least, is to give a bit of help to the newcomer segment of the audience. So in other words, the people who are completely new to the Java platform. So for you folks, maybe you're just getting started, maybe you're trying to get started, maybe you don't even know how to get started, and that's okay too. But these next few episodes, these are going to be for you. So yeah, on the whole, this podcast is designed for both beginner and intermediate level Java developers. And it would be nice if there's some kind of way of being able to aggregate the beginner content separately from the intermediate level content. And maybe there's a way of doing that going forwards in the future where we can somehow separate out into different seasons based on the level of knowledge of the audience. But for now, the best we can do is to just let you know in each episode, in the description of each episode, that is, who the intended audience is, so whether it's beginner or intermediate level. And hopefully everyone can listen along anyway, because there's going to be beginner stuff in there that might be still interesting for intermediate people who can have a bit of a refresher on that kind of stuff. And going the other way, for beginners to listen to the intermediate level stuff, that might be a bit trickier, I'd say, so probably I wouldn't recommend that for beginners to listen to intermediate level episodes, but certainly intermediates can listen to beginner level episodes. Anyway, let's jump in now with the content for this episode. And that's where we're just going to give a kind of an overview of Java itself, what it's all about, and some of the background to the platform. So, Java started out as a programming language back in 1986, I think it was, and it was developed by a guy called James Gosling, who's typically regarded as the grandfather of Java itself, the whole platform. It was his baby, if you like. And it started out as a programming language called Oak, which was to do with the fact that James Gosling had an oak tree outside his office, which you could see apparently. That was part of something called Project Green, which was Sun Microsystem's attempt to develop software for set-top boxes. So those are the devices where you can receive different television channels and route them into your TV. Now if you fast forward 10 years and jump to January 1996, that's when the first release of the JDK came out, which is really when the Java programming language and the Java platform itself was born. The language was renamed, by the way, from Oak to Java because of some kind of like trademark conflict or something. Anyway, so yeah, January 1996, JDK 1.0 is released, which is the first proper version of Java. Now, at this point, we could go on about the different versions of Java that have come out. It goes right up to Java version 17, which came out in September 2021, although nobody's using releases that are as new as that. In general, most people tend to use Java 8. But yeah, we could go through all the different versions and everything. That's probably not that interesting to a beginner. What's probably more interesting is an understanding of the Java platform itself, because there are various different acronyms involved which represent the platform components. So we've got the JDK, the JVM, the JRE, and I've got to say it's confusing, I think, to a beginner, how all these pieces interconnect, and indeed why there are these different pieces. So let's just dig into that right now then. Let's talk about the Java platform itself. Actually, even before we talk about the Java platform, let's talk about the word Java, okay? So the word Java is confusing because it can mean multiple things. It can mean the Java programming language that you write your computer programs in, and it can also mean the Java platform, which is the kind of collection of components which work together to allow you to create Java programs and to run them, which you do largely with the JDK and the JVM, which we'll come to shortly. And it's confusing because the word Java can mean both of those things. So the best way to interpret things, the best way to look at it, is to basically just think of the Java platform itself and what it does. So the idea of Java, the big sell, the big idea, if you like, is the fact that Java allows you to write programs in a platform-independent way. And what that means is that you can, for example, write a Java program on a Windows machine, so a machine that's got the Windows operating system installed. Any version of Windows, by the way. So Windows 11, Windows 8, Windows XP, Service Pack 3, whatever it might be. Going back quite a bit now. Windows Vista, whatever it might be. All of the machines which run those operating systems, they're thought of as a Windows platform. So you can write a Java program on a Windows machine, which is using one of those operating systems, and then you can effectively run that program that you wrote on Windows, run it on any other platform. So for example, you can run it on a Mac, and again, any versions of Mac. So Sierra, High Sierra, Snow Leopard, Jaguar, whatever the different versions are of Mac OS X or Mac OS X. Those are Mac platform machines, or on Linux-based machines either. So that includes all the different versions of Linux out there too. There are tons of those as well, so Fedora, Red Hat, Ubuntu, SUSE Linux, all of those. And you can also still run it on a Windows-based machine as well. Now, if you're a complete newcomer to Java, and indeed a newcomer to computer science in general, then it might not seem particularly impressive. And that's because the fact that you can write the program once on one platform and run it anywhere on any other platform. By the way, that's an acronym there that's also used with this, is WARA. So write once, run anywhere is what it stands for. This notion of being able to write on one platform and then run it on any other platform. And yet it might not seem that exciting. But to put it into context, what we used to have to do pre-Java was you'd write a computer program with a specific programming language, and you'd what's known as compile that program so that it would run on that same platform. So if you wrote your Windows program using C++, for example, you'd only ever be able to run that program on a Windows-based machine. If you developed a Mac program with Objective-C, which was Mac's main programming language, an extension of the C language, which has now been replaced with Swift, again, you'd compile it, and it would only be able to run on Mac computers. And the same goes for Linux as well. So from that point of view, the three main types of platform, Windows, Linux, or Mac, had no form of cross-compatibility with respect to the software that you wrote. That means that if you had a program in Windows, you had no alternative but to rewrite the exact same program on Mac and effectively have to port across the Windows version, programmed in Visual C++, using all of Microsoft's foundation classes and their kind of framework for doing things and all their libraries with all different method calls and different API calls that you could use. You'd have to port that across onto Mac and write it using all of the Mac libraries. So you'd have to use Cocoa or Carbon, and again use all of the method calls and APIs that are part of those libraries. And those libraries would be completely different from one another as well, which would make it an almost impossible task. In addition to that, the actual technologies are different. So on Mac, it'd be based on Objective-C, which is a different programming language from Windows, which is in C++. And you had a similar issue as well with Linux. So yeah, you had no cross-compatibility between different systems. Now, what Java wanted to do from very early on was be platform independent, so to not have that restriction. So that's not just a problem for writing commercial software. So for example, you have a development team who build an application in Windows, and they also want to release it to not just the Windows market, but also to the Mac market as well. That's not just a problem there, but it's also a problem from the point of view of corporate organizations. So if you forget about commercial software when you're buying, or when you used to buy rather, a piece of software off the shelf, so you go to stores like PC World or Best Buy, and back in the day you'd buy a physical CD-ROM with the application on it, and you'd have to see if it's a Mac version or a Windows version. If we forget about that kind of like commercial software side and think to something more commonplace, the more commonplace issue is where you have a corporate organization that uses a programming language for a different purpose. So for example, to do some in-house application, say. So let's supposing you're like an e-commerce store or some kind of company, you've got a website, you've got a web application there, and somehow your business model is based on serving consumers through some website which is backed by a web application on the back end, which is running in some server room somewhere. Even in that scenario, you've still got this need to have this cross-compatibility, because what will typically happen is developers will be given cheap laptops or cheap computers to develop on, so to write the programs, and those are going to be Windows-based machines because they're the cheapest machines to get. Macs in general are far too expensive for most places to use. And by the way, if you're at an organization which gives you a Mac, you should be really thankful for that because it's pretty rare that you get that, particularly as a Java developer. But yeah, so an organization will give developers cheap laptops or cheap desktops to work on, which don't cost an awful lot of money. They'll have a vanilla version of Windows installed on it, which is also, by the way, not the best experience for developing software. Once you get to a semi-pro or a professional level, you tend to be using Mac-based systems or Linux-based systems to do your software development because there's so much more tooling and so many more tools available out of the box on a Mac, for example, that you just don't have in Windows. But anyway, yeah, you've got these companies, they give the developers cheap laptops to work on, or cheap desktops to work on, and that's okay because the resources on the computer, they're only going to be used by one person, and that's the developer. the programmer who's programming the program, that's the one and only one user who's using that machine at any one time. However, on the flip side of the coin, when you're developing web application software and web apps, then you deploy, that kind of means install, you deploy those web apps on a server. And that's pretty much just a much more souped up version of a computer with much, much better hardware. So more memory, faster processors, that kind of thing. And the reason for that is because it's not just serving one person who's using the machine, it could be servicing, say, 1,000 people at the same time, or 10,000, or 100,000. If you've got 1,000, 10,000, or 100,000 people accessing your website at the same time. So necessarily, the hardware there in this server needs to be much more powerful than the hardware that the programmer uses, because it's thousands of people using the server versus just one person using the desktop computer. Now, Windows isn't very good at providing a decent environment, a performant environment that is, for servers. So therefore on most servers you don't find Windows installed. Instead you typically find Linux. So Linux or Unix, that's what you'll find on most servers. So now we can start to see this kind of cross-compatibility need, whereby the programmer is writing the web application code on his or her Windows machine, but then when it's deployed to be run, it's going to be run on a Linux-based server machine. And as we've said before, traditionally, prior to Java, this wasn't possible. So the fact that Java came along and gave us this write once, run anywhere ability is a pretty phenomenal concept and was absolutely revolutionary when it came out in 1996, the first version of the Java platform. So the next question then, I guess, is, okay, so how does Java actually manage to do platform independent stuff? How is it possible to write code on a Windows machine and then run it on a Mac or on Linux? So central to Java's write once, run anywhere ability is the JVM. So the JVM is the runtime process which runs Java programs. So just like a microprocessor can run machine code, the JVM, which stands for Java Virtual Machine, can run something called bytecode. And bytecode, effectively, you can think of it as being machine code from Java. Now we'll come back to that in a second, but effectively the idea is that all platforms that support Java and are going to participate in this write once, run anywhere thing, they'll all have a JVM available for them, which allows Java programs to run on them. So this means you're going to have a JVM for Windows, you're going to have a JVM for Linux, and you're going to have a JVM for Mac. And also not just that, where you've got different flavors of the operating system. So for example, Windows 32-bit and Windows 64-bit, you'll have corresponding flavors of the JVM as well. So there's a JVM for Windows 32-bit and there's a JVM for Windows 64-bit. So at this point we know that as long as we have any machine and that machine has the JVM on it for that machine, then it will be able to run Java code. But it's a special form of Java code that's called bytecode. So that's one piece of the jigsaw. Now the other piece is, or rather the next question is, okay, so what's bytecode? Well, bytecode is the compiled format of the Java code that you write. So as a Java programmer, I write programs in the Java programming language, and then I feed that program to a thing called the Java compiler. And the Java compiler's responsibility is to take that Java code, which I can understand because I'm familiar as a Java programmer with how Java programs should look and what the syntax is, the combination of funny characters and these special keywords that use that kind of thing. That's something that I can deal with. And that's because Java is high-level programming language. In other words, it's a programming language which is close to humans. That's where the high-level part comes from. It's high up to humans. The opposite of that is a low-level language. And that's lower level because it's closer to the computer and what the computer can understand. So the lowest form of the lowest level language is binary. So just combinations of zeros and ones. Going up from there, we have hexadecimal, which are those funny numbers which have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and also the letters A, B, C, D, E, F. Going up one step further, we've then got machine code. Going up another step further, we've got assembly language. Another step further, we've got things like C and C++. Then we've got Java. Now we're getting really high level now. You don't have to know too much about that, but the main point is that the programming language that you can understand and that's easy for you to communicate what the computer should do, that's high level, and that's what the Java programming language is there for us. So this Java compiler then takes that high level programming language code that you've written, which you understood, and then it converts it into the low level code that the JVM can understand. And so this low level code that the JVM can understand, this is this bytecode, which effectively is machine code for this process called the Java Virtual Machine. This means that if you try and look at the bytecode, and there are ways of being able to inspect what this bytecode actually looks like, you won't be able to understand it because it's so low level, it's almost meaningless to look at. As you become experienced with Java, you can read it and understand it. I can understand bytecode if I get a copy of it by using a thing called a disassembler. At least I can understand it to a reasonable degree as a Java programmer, but I certainly can't understand all of it because it's not designed for human consumption. It's not designed for us to be able to read as programmers. It's designed for the JVM process to be able to read and to execute. In other words, to run the instructions that are in there. So there's a lot of concepts there to unpack, but in a nutshell, you, the Java programmer, write your program in the Java programming language. This is a high-level programming language, which means it's understandable to you. You give that to the Java compiler. The Java compiler converts that, actually compiles it, that's the word we use for that, compiles it into the lower level bytecode, which is a form of machine code, which is understandable and can then be executed, that means run, instruction, by the JVM, or the Java Virtual Machine. The JVM, or the Java Virtual Machine, there'll be a version of that for whatever target operating system the machine you want to run that Java program on has installed. So Java programming, feed it into a Java compiler, bytecode comes out, the JVM runs that bytecode. And because JVMs are installed and available for all different types of operating system, Windows, Mac and Linux, that's how you can write once on Windows or Mac or Linux and then run anywhere, again on Windows, Mac or Linux, because of how those platform components have been arranged and what they provide. So this brings us then onto these three acronyms, the JDK, the JRE and the JVM. So in the beginning, there was just the JRE. That stands for the Java Runtime Environment. And what it does is, as its name says, it's the runtime environment. So it enables you to run Java programs. Now, if it enables you to run Java programs, where do those programs run on? We just mentioned that. We said that Java programs run on the JVM. That means that the JRE was a package which happened to include the JVM. It includes a lot more besides, but fundamentally it includes the JVM, which is what can run, or that's also known as execute, the Java program, the bytecode, along with all of the actual library code and a few other bits and pieces as well, which comprise all of the library code, all of the framework, if you like, which your Java programs can use for free. So the stuff, in other words, which comes out of the box with Java. So Java gives you APIs, that stands for Application Programming Interface, gives you APIs for thousands of different things which you can do. Everything from opening and reading files, writing data to a socket, that's a web connection, running multiple threads, that's doing parallel execution of programs, doing things with cryptography, things with drawing windows and menus on screens, even things as obscure as image manipulation. There's so much stuff in Java, the out-of-the-box Java Standard Edition library, so that's Java SE, the Java Standard Edition. There's basically Java Standard Edition and also Java Enterprise Edition, but the out-of-the-box version is Java Standard Edition, and there's so much stuff in there available completely for free that it's actually pretty mind-boggling. But anyway, yeah, in the JRE you have the JVM, which can run the Java program in bytecode form, and you have the collection of libraries to make up the Java platform itself that you can use. So that's the JRE. Now, why is there a JRE in the first place? Why is there not this compiler thing you're probably saying, the Java compiler? Well, that's because not everybody is going to have the need to be able to develop their own Java software. So it doesn't make sense to put a Java compiler in there as well, because it's just a runtime environment. And at runtime, you don't do anything to do with compilation because you've already done that previously at development time. So when you've been actually developing the software, that means programming it. So at development time, when you're actually developing the software, that's where the JDK comes in. And that stands for Java Development Kit. And again, the clue is in the title. It's the kit, in other words, the collection of tools and resources which allow you to develop Java programs. So the JRE, the Java Runtime Environment, where you can run the programs, has the JVM in there, which runs this bytecode. The JDK, the Java Development Kit, allows you to develop the programs, and inside that, it has the Java compiler, and that Java compiler can take these Java programs, written in the Java programming language, compile them, turn them into bytecode, and then run them on the JVM. Now, it used to be that the JDK and the JRE were separate entities, but instead, nowadays, it's much simpler. The JDK also includes the JRE bundled with it. And as a Java developer, you don't really care. You just know that you've got two command line tools in there. Those are commands that you can execute from either a DOS prompt in Windows, that's the big black screen where you type commands in, which you may have seen, or the equivalent terminal session on a Linux-based system or terminal session in Mac. And those two commands are javac, so Javac, which stands for Java compiler. So it's Java and then C, which stands for compiler. So that's javac, or Java C, as it's sometimes known. And that's the Java compiler, which you'll find inside the JDK folder structure. And the JVM is the command Java, just Java on its own. And that's the command which is actually the JVM itself. Now, when you install the JDK onto your system as a Java developer, it will be installed into a directory onto your machine. And you can also choose where you install that to. So I normally install mine, for example, if I'm using Windows, into C:\/Java/ and then whatever the JDK name is. So 1.8.0 202, for example. It will look something like that, which is the actual version of Java that you're installing. It encodes it, if you like, into the name of the directory. So I'll install it to something like c:/java/jdk 1day.0_202. And what we do then at that point is we create a thing called an environment variable, which we call java_home in capital letters. And inside that environment variable, that's where we put this path or this directory. And what environment variables enable us to do is it allows an operating system to declare a piece of information which might be useful to other programs. So java_home as an environment variable, which you'll find on all Java machines, at least all machines that are used by developers, that's always going to have the directory of where the JDK has been installed to. And then once you have that environment variable, you then use that to add to another environment variable, which is known as the path or the system path. And you'll basically include then the bin subdirectory of that folder into your system path in terms of that Java home environment variable. So what this means basically, in a nutshell, is you'll see an entry like %java_home%\bin if you're on a Windows-based machine, or if you're on Linux or Mac, you'll see something like $java_home/bin, and that'll be part of your path. And what the system path is, that environment variable, it's basically a collection of directories which are separated by either a semicolon in Windows or a colon in Linux or Mac. And it's a set of directories which are searched in order. Don't forget they're separated by this colon, so the first directory will be the set of characters before this initial colon, then the second directory will be the one after that, but before the next column, that kind of thing. Yeah, the system path defines the set of directories which are searched in whenever you enter a command, either a DOS prompt or a shell or a terminal session. And that's why when you install Java for the first time, the JDK rather, for the first time, you need to ensure that you put this, effectively java_home/bin, you need to put that into your system path. And that's because if you don't do that, then when you type javac or javac to invoke the Java compiler, or you type java to invoke the JVM, obviously there are extra arguments or extra parameters you need to pass to that command, but forget about that for now. Whenever you issue a javac or a Java command, if you don't have the java_home/bin component added to that system path, then it won't be able to find the Java compiler or the JVM. And conversely, of course, if you do have it and you do include it, then it can find it. And at that point, then you're good to go and your JDK is set up correctly. Bin, by the way, is a subdirectory. It stands for binary or binaries, and that's basically, it's a throwback from the old Unix and Linux days, but it's just the name of a directory which typically contains command line tools that you can run. So I hope your head isn't exploding at this point. It's all fairly straightforward once you get used to it, but the first time you hear it, it'll be pretty difficult to visualize, I'd imagine. But hopefully you can understand what I was saying, and it helps to demystify a lot of how the Java platform hangs together in terms of the components that it comprises. Now, if you want to have a hands-on tutorial for that, there's actually a course which you can take on the Java Easily website. So if you go to courses.javaeasily.com, that's courses.javaeasily.com, and if you search there, then there's a nice course there which gives you a complete introduction to Java, the Java platform itself, the tools you use, how to set them up, and gives you a run through of what it's like to code in Java by looking over the shoulder of me as I code something up and show you around. So that's really useful. Take a look at that if you can. That's really an excellent thing to get started with. Also, if you haven't joined the Facebook group as well, then feel free to join that too. You can search it in Facebook itself, and it's called Learn Java Easily, the Java Programming Mastermind group. And that's a nice, friendly place to be able to help you out with all things Java. So anyway, I hope that was useful, and until next time, take care, stay safe, and speak soon. Bye.